Okay, so these are the solutions to the problems about testing a claim about a mean using a p-value. In the first section here, we have Garrison Forest will graduate more than 65 seniors per year. So that's a claim about a mean. So the null hypothesis here is that the mean, well, let's see, the mean in the null hypothesis is always an equivalent state. So the claim is going to be the alternate hypothesis here, because the claim is a more than statement. So that's going to be greater than. Since the alternate hypothesis is a greater than statement, this is a right tail test. And now we have some additional data that we need to do some entering here in order to evaluate that claim. So this is where we break out the calculator. Okay, so this is a claim about a mean. So what we need to do here is we need to do what is a t-test. And we're going to use the statistics. So the mean that we're testing is against 65. The mean in the sample here, according to this, was actually 72. The standard deviation of the sample was 5, and the sample size was 30 different years. This is a right tail test, so we're going to calculate. And the p number there is like 9.34 times 10 to the negative 9. It's a very small p number. So let's get that onto our other paper and then make some. Alright, so in problem number 3 here, we're given that p is 9.34 times 10 to the negative 9th. In this case, p is less than 0.5. So we can go ahead and reject the null hypothesis. Now remember that the claim here is that there will be more than 65. So rejecting the null here actually supports the claim. So we could say that the data supports the claim that GFS will graduate more than 65 seniors per year. Right, so there you have that. All right, so let's look at problem 2 here. Problem 2 says that there are less than 17 French fries in a McDonald's Happy Meal. So the null hypothesis here is always an equivalent statement, so that's that the mean is 17. The alternate hypothesis is going to reflect our claim that the mean is less than 17, right? And since this is a less than statement, we're talking about a left tail test here. And now we need to perform the test, and we're going to need the calculator for that. All right, so this is going to be another t-test, right? The way that we handle this is that we make the mean is 17, which is what we're testing against. We took a sample and we found that there were on average 15 in the sample with a standard deviation of 1.2, and we bought 6,000 Happy Meals to do this, okay? This is a left tail test. And when you do the calculation on this, something absolutely fascinating happens here. It says that the p-value is 0, which means that it's just so small that the calculator actually just rounds whatever the p-value was to 0, because it's like at least lower than something times 10 to the negative 15. So your calculator is actually assuming that that is 0. So in this test, we're going to say that p is 0. And 0 is definitely less than 0.05. So this means that I can clearly reject the null hypothesis. And given that rejection and that the claim here is the alternate hypothesis, I can say that the data supports the claim that there are, on average, fewer than 17 French fries in a McDonald's Happy Meal. All right, so that's problem number 2. All right, looking at problem number 3. This problem is a little different from the other ones that are on this page. You are being told that more than 5% of all high school seniors are afraid to graduate, and then it says, careful, read the claim carefully. What are the null and alternative hypotheses that correspond to this claim? All right, so we need a null hypothesis, we need an alternative hypothesis, but this is a claim that is qualitative and not quantitative. Okay, so the quality here is afraid to graduate. So we have a proportion of the population, 5%, or more than 5%, which is what the claim is, that is afraid to graduate. Part 2 on this is that this is a right tail test. Okay, it's a right tail test because we have a greater than statement. Part 3 asks a new question here. Should I be using a t-test or a 1 proportion z-test? You should be using a 1 proportion z-test here because this is about a proportion and not about a mean. Let's actually conduct that test with the calculator here. All right, so this is going to require me to do a 1 proportion z-test. We're testing against 0.05%, right? 5%, not 0.05%, but 5% of the population. In the test, you have to be a little careful here. It's like how many people actually are afraid? Well, it says that it's 6%, right? 6% of 500. Well, 6% of 100 is 6. 6% of 500 will be 30. And then we tested 500 people. This is a right tail test, and that standard deviation is irrelevant in this problem. So we're going to go and calculate the p-value. The p-value here comes out as 0.152. Let's get that transferred over. Okay, so we just said that the p-value that was generated from the test here is 0.152. Now that p-value is clearly bigger than 0.05, which means in this case we fail to reject the null hypothesis. The p-value is adequately large. So since the claim is sitting in the alternate hypothesis here, we say that the data actually does not support the claim that more than 5% of all high school seniors are afraid to graduate. All right, so this is a case where we fail to reject the null, and since the claim is in the alternate hypothesis, then we know that the data is actually not supporting the claim. All right, so let's look at the 4th problem here. So the claim in the 4th problem here is that on average, more than 1,000 car accidents a day happen in the United States because of cell phone use. Okay, so let's get the null and alternate hypothesis here. The null hypothesis, this is again a claim about a mean. The mean is 1,000. We're making a claim that it's actually higher than that. And part 2. This is a right-tailed test because it is a greater than alternate hypothesis. 3 asks, should I use the t or the 1 proportion z? This is going to use a t-test because we're making a claim about a mean here, okay? So let's actually do that t-test. All right, so I'm going to go stat tests t-test. We're doing statistics here. The mean that we're testing against is 1,000. The mean in the sample was 1095. The standard deviation of the sample was 470, which is really large here. And the number in the sample was 365. This is a right-tailed test. We calculate, and the p-value here is like 6.664 times 10 to the negative 5th, which is really tiny. So let's get that onto our other page. All right, so let's look at number 4 here. The p-value that we got here was 6.664 times 10 to the negative 5th. That value is clearly less than 0.05, so we have to reject the null hypothesis, but remember that our claim is the alternate hypothesis here. So number 6, we say that this data supports the claim that on average more than 1,000 car accidents a day are caused by cell phone use. All right, so there is all 4 problems and all 4 responses. Again, if you have questions, email, do one of the drop-in sessions, and we'll go from there. Thank you.